Good morning. My name is Coy Wedderburn, and this 6 weeks project covers polar curves. Polar curves are shapes constructed using the polar coordinate system, where the curves are defined by points that are a variable distance from the origin, depending on the angle being measured off the positive x-axis. Polar curves are most useful to describe paths, which are an absolute distance from a certain point. With there being an unlimited number of polar curves, I have chosen to discuss the Lituus and Tricuspoid curves. The Lituus curve has been around since the 1700s. The polar equation for the Lituus curve is r squared equals a squared over theta. Lituus means crook, which is the hooked staff of a shepherd. Roger Coates was the first person to study this type of curve. Maclaurin gave the curve its name since it resembled the curve of a bishop's crosier. The original use of the Lituus curve was used as a cult instrument in ancient Roman religion by augurs to mark out ritual space in the sky. The current use of the curve is unknown. The tricuspoid curve belongs to the family of curves called hypocycloid. This curve got its name because of its three cusps. The Cartesian equation is open parentheses x squared plus 12ax plus 9a squared close parentheses squared equals 4a open parentheses 2x plus 3a close parentheses cubed. The parametric equation is x equals a open parentheses 2 cosine open parentheses t close parentheses plus cosine open parentheses 2t close parentheses comma y equals a open parentheses 2 sine open parentheses t close parentheses minus sine open parentheses 2t close parentheses. The tricuspoid curve is also known as a deltoid curve, dated back to 1745. This curve has been connected with an optical problem. The latest use of this curve shows a small circle rolling like a wheel inside of a larger circle. The tricuspoid is created when the radii of the circles has a ratio of 3:1. The two gentlemen given credit for the creation and further research of this type of curve are Steiner and Euler. Thank you for your time today and listening to my presentation on polar curves.